I'm Tommy Peagler, Forestry Instructor at Coastal Pines Technical College in Waycross, and we're here this morning to look at doing some timber cruising. First, I want to talk to you a little bit about some of the equipment we're going to use today. This stick here is called the cruising stick or plot stick, and we'll be using it in just a minute when we get into the woods and we put our plot in. Some of the other equipment that I have on is obviously the cruising vest I have. Not only is it visible, so we look official while we're in the woods, but also during hunting season, when we spend a lot of time in the woods, we want to be seen, and it's got a lot of pockets on it, so we can carry our stuff. One of our pockets here, I have my compass that I'll be going over with you in a minute. A compass is a forester's way to be able to navigate in and around the woods. It's got a north arrow that always points to the north. Today our north direction is this way. So anyway, our compass is a trusty friend in the woods. Another tool that we use is the clinometer, and though some of these instruments are pretty small, they can be fairly expensive. This clinometer runs around $130, but it has no batteries. There are some electronic clinometers out there today. This clinometer we can keep all in our vest, so we're ready to go when we get into the woods. So the clinometer is used to get tree heights. So I'll be demonstrating this in a minute. Another item that I have in my cruising vest is actually just a roll of flagging tape. And I may get back here in the woods and I may find a corner, a landline corner. I may find an old tree that's been flagged or has hack marks on it that I want to reestablish. An old line, an old survey line. I also use it sometimes to mark my plot when I'm on my cruise plot. So anyway, the flagging tape comes in handy. The other item that I have here is the tally book. My tally book is where I record my notes while I'm cruising timber. I actually have grid paper on one side of my book, and on the other side of my book I actually have the tally sheet where I'll be putting in my trees as I tally them, and some other information in terms of product like pine pulpwood and pine chipping saw. In this stand today, we're looking at about an 18-year-old stand of slash pine that's been planted. We will have some pine pulpwood and pine chipping saw, and we won't have any saw timber today, and we won't have any poles in this stand, but this is our tally book. One of the most important items for a timber cruiser and cruising timber is the diameter tape, and this is often called a logger's tape. And this tape is calibrated. On one side it is inches and feet, so when I want to go to my cruise plot, which is 1/10 of an acre, which is 37 feet 2 inches, 1/10 of an acre, 37 feet 2 inches, I can go out from my plot stick out 37 feet 2 radius all around my plot. Everything inside of that is merchantable or can be sold will be a part of my tally that I will put in my tally book. The other side, it's actually calibrated for tree diameter. Okay, so one side of the tape is calibrated with inches and feet, the other side of the tape is calibrated for diameter. I will be demonstrating this in a few minutes as I wrap this tape around a tree and get that tree diameter. The tree diameter is one of the measurements I need to be able to get tree volume. The other thing that I need for tree volume is actually tree height. Okay, so I'll be getting the height with the clinometer, okay, that I demonstrated earlier or showed you. The other item I'll need for volume would be that diameter of the tree. So we're out here right now. We're on the edge of the woods with dirt road running here behind us, and our forestry bus here. One of the things that I want to do now is I want to go put a plot in the woods. One of the things about putting a plot in is I want to make sure that I am on in the woods at least a chain. Okay, a chain is 66 feet. Okay, for me to get to a chain, for me to travel to a chain as a forester, I've got these two items. Okay, I've got my legs to basically get me around in the woods. So I need to know how far or how many steps is it going to take me to get to 66 feet. And also my map that I showed you is calibrated on there for 66 feet increments. As I travel in the woods, I can stop at those increments, I can make notes, or I can put a plot in. So 66 feet, okay? So 66 feet is going to be how many paces does it take me to get there, okay? And a pace is 2 natural steps, okay? And this is not somebody trying to step out and make a long step like you're trying to step off a yard, okay? If I'm trying to pace, I'm basically trying to take what would 2 natural steps look like, okay? When I travel 2 natural steps, what does that look like, okay? And one of the things that I'll demonstrate, and I'm not going to go into detail today with that, but one of the things that I want to demonstrate at some point is how to pace, how to learn how to pace. Basically, you're going to set yourself off 100 feet or 200 feet that you measure with a wheel or a measuring tape, and then you're going to walk that, okay? And you're going to keep up with every other step, okay? If you lead with your left, you would count the right foot every time your right foot hits down, okay? So you would keep up with how many paces. You would take that and divide that into what the feet is, and that's going to give you what we call a pace factor. Pace factor is how far do you travel in 2 natural steps, okay? For me, I travel 5 feet in 2 natural steps. If you're tall, okay, means your stride's going to be longer. You're probably going to cover more than 5 feet in 2 natural steps. If you're shorter, you may travel 4 feet or 4.5 feet in 2 natural steps, okay? So everybody's pace factor is going to be different, okay? So what that means is, if I travel 5 feet in 2 natural steps called a pace, then I'm going to take 66 feet, I'm going to divide that by 5, and that's going to be what my paces will be to 66 feet, okay? So in just a few minutes, I'm going to be demonstrating how to pace to my plot, okay, where I'll put my plot stick down, and then I'll put a plot in, okay? So one of the things that I want to demonstrate now is, I want to demonstrate the compass and how to read the compass and how to establish our line that we're going to take as we traverse through the woods. Okay, one of the things I want to do now is I want to create my cruise line through the woods. And the way I do that is I actually create a baseline. So I need to get a true line that's on the edge of my tract or my stand, so that I can create a perpendicular line that's going to carry me into the woods. So one of the things that I'm going to do right now, you can't see it on the camera, there's a dirt road out here to my right. On my left is the timber that I want to cruise. What a timber cruise is basically an appraisal of this timber, the value, volume is what we're going to be getting today, and then we're going to put a value on that volume eventually to see how much wood is here, how much monetary value. Before we do that, we've got to put a line in. We've got to put a cruise line in. So I'm about to open my compass and put a baseline in. So as I look at my compass, I'm using the compass mirror to be able to see the face of the compass. So I'm able to look through it, and I've got a sight right here on the top of a V sight right here on the top of my compass. So as I turn my compass, I am turning the dial of my compass so that it is directly under the floating north arrow. So inside of this compass is a north arrow that no matter how I turn this compass, no matter what way I turn this compass, this north arrow is pointing that way. I can turn this compass completely around, and that north arrow is turning that way. So as I look at this again and I set my baseline, okay, as I set my baseline, I position the dial that I control, and there's a large arrow that I put underneath the floating red arrow, and then I read it. This direction is north 8 degrees west. So my baseline bearing is north 8 degrees west. Now I want to create a right angle here, okay? So I want my cruise line to create a right angle between this baseline that I just established, okay? Which, by the way, is also running parallel with the dirt road right out here behind me on my right. As I go into the woods here to my left, I want to create a cruise line. So if I turn, if this is north 8 degrees west and I want to turn 90 degrees and I want to go into this stand of timber, then I need to turn my compass to that bearing. So if my cruise bearing or my base bearing is north 8 degrees west, what would 90 degrees look like if I turn and head basically to the right, creating a right angle here? Well, if I turn this 90 degrees, I am going to be at south 8 degrees west, okay? Or actually south 82 degrees west, okay? So if you take the north 8 degrees west, which is my baseline, and I want to create a right angle, then I take 90 degrees from that as I turn, and my cruise line is going to be south 82 west. 82 plus 8 is 90, okay? So I've created a right angle here. My next step is to take the compass and to go in here and actually establish my plot. That's the next thing we're going to look at. One of the things we want to do as foresters is we want to be able to pace to our plot. So knowing how to pace is very important, okay? So when I'm in the woods, some of the things that I have on to be able to be seen, I've got my cruising vest on, I've got my pockets with my tally book, and I've got my clinometer, my flag and tape, I got my compass in my pocket. And I want to go in here now and I want to put some plots in. I want to see how much volume of timber is in here. One of the things I need to do is be able to pace to my plot. So what is a pace? A pace is 2 natural steps. 1, 2. That's one pace. So if you want to go with me, I've already got 66 feet measured off here. So I'm going to pace for you 66 feet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 paces for me to get here to 66 feet, okay? I'm going to go back now again, then I'm going to compute. I'm going to say 66, okay, divided by 14 is going to tell me my footage between each pace, okay? So here we go again. Remember, a pace is 2 natural steps, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So by me getting 14 down and 14 back, I've already measured off this is 66 feet. Now, I'm going to see what is my pace factor. Go on my phone, pull up my calculator. 66 divided by, took me 14 paces to cover 66 feet, 4.71. 4.71, that is my pace factor, okay? So every time, with 2 natural steps is 1 pace, every time that I do that, I've just covered 4.71 feet, okay? So if I'm walking somewhere and I take 2 natural steps, that's what my pace factor. Some of the things that can cause you to have an incorrect pace factor is you've got really rough woods, your steps may not be accurate. If you change shoes, okay? If you change shoes and you maybe wear another pair of boots or steel-toed boots or, you know, some different shoes, that could affect your pace factor. If you do change shoes, you may want to reset your pace factor. Set you a course up 66 feet, pace there and pace back. Divide your paces into 66, and that's going to give you your new pace factor if you need it. So today for me, my pace factor is going to be 4.71. So I'm going to travel into this stand one chain, okay? My bearing that I'm going to travel into this stand, remember, we set a bearing, a baseline bearing that's running along these trees right here. We set that, remember, we set it at north 8 west for our baseline. And we're creating a right angle. So we're turning perpendicular to this baseline. And that is going to give us, going in a westerly direction, that is going to give us a cruise bearing of south 82 west. So when I go into the woods in a few minutes, I will be traveling at a bearing of south 82 west, which creates a right angle right here with my baseline bearing that was north 8 west. Okay? Okay, so one of the things I want to do before I come in and get some volume for this timber that's behind me, which is termed a stand of timber, is I want to make sure that I'm going in the right direction. I also want to make sure that I get back out to this clearing that I'm in. So I want to create a baseline. So one of the things that I do, I set my cruise stick down, I take my compass out, and I shoot a bearing. And my bearing is basically running in a straight direction along the side of this stand of trees. So when I take my compass out and I shoot the baseline, I've got my red floating arrow that's always pointing north. And in this case, north is in this direction. No matter how I turn my compass, that red arrow is always in that direction. What I can control is the base of the compass, this dial. It's called a dial. So as I turn the dial, I line the dial up with my red arrow that's on the dial positioned directly under the floating red arrow. And when I do that, I look down at my compass, and at the very top of my compass, I have a white notch. And then I read the bearing, and it says north, and 0 is on the right side of that. So I read it back around to the white notch, and it says north 8 degrees west. So north 8 degrees west, that is my baseline, okay? I want to create a right angle with north 8 west. I want to turn in a westerly direction, and I want to create a right angle right here, so that when I go into the woods, I'm running a straight line that's perpendicular to my baseline. So north 8 west, if I turn my compass 90 degrees, if I turn my compass 90 degrees to the west, I'm now at south 82 west. Okay? Think about it. 82 plus 8. Remember, I was at north 8 west. 82 and 8 equal 90. So I've created that right angle. Now I want to turn my compass, and I want to look at the very top right here of my sight. Okay? So as I have my compass, basically this is creating like a 45-degree angle. I have a mirror. I have a sight mirror that's in here that allows me to get a reflection of the face of my compass. So as I look at my compass, I'm looking at my dial. My direction is going to be straight through here, okay? So one of the things that I'm looking at is I'm looking at the notch right here, and then I'm looking in the future through the notch. I'm looking out in the distance ahead of me, and I'm finding an object, maybe a tree or a bush, could be a limb, anything that's a landmark for me that I can walk to. And those walk, remember, is called a pace. So for me to travel 66 feet, which is every time I take 2 natural steps, I've covered 4.71 feet. For me, it's going to take me 14 paces to get to 1 chain, which is where I'm going to put my plot at. I'm walking down the baseline till I get to 66 feet, which is 1 chain. As I walk down the baseline, I'm going to stop at 1 chain. I'm going to turn 90 degrees or a right angle, and at that point I'm going to walk into the woods to my cruise plot. Okay, what I want to do now is I want to go in and I want to put a plot in. We've created our baseline. Remember, we said our baseline was north 8 degrees west, okay? Then we turned 90 degrees from that baseline, created a right angle here. My cruise line is south 82 west, okay? So I'm going to go, I want to get to the edge of my stand. Always start your pacing at the edge of your stand, okay? So I'm going to start from here, and remember, for me to travel 66 feet, that's going to be 14 paces. So every time I take 2 natural steps, I'm covering 4.71 feet. We've already established my pace factor, okay? I want to look through my compass. I want to look through the top of my compass. I want to find an object, a tree, a limb. I want to find some landmark in the distance that I can pace to, okay? For me, I found it. There's a pine tree that's a little more crooked than some of the others that I'm gonna pace to. So I found it, put my compass back in my pocket, okay? Still looking at that tree that I'm gonna be going to. I'm gonna pace 14 paces to my cruise plot. I'll put my stick down there, and that's where I'll take my plot at. So here we go. 1, 2. So 14 paces. So I'm in my stand of timber now, and this is going to be my first plot. So I come in 66 feet, which is 14 paces. I got off the edge. We want to get away from the edge. We want to be able to get out here where we can get a good plot in. The timber we're in today is it's planted pine. It's slash pine, roughly around 18 years old. A lot of times you'll know the age of the tree about a landowner will let you know when it was planted. The other way is to just have a sense of the area and how fast the trees grow. Typically trees grow about, pine trees in this area grow about 2 feet a year. So these trees are 40 to 45 feet tall. So giving them an age of, basically 18, 19, 20 years old, okay? So the next thing we want to do now is we want to put our plot in. So that's why we're here. So a lot of the things leading up to putting our plot in has been creating a baseline, then creating a cruise line that we came in. Now we've made it to our plot. At this point, we want to start tallying trees, okay? So I have, in my cruise vest, I have a tally book. And inside my tally book, I have a tally sheet. And on my tally sheet, I have the landowner. So the landowner here today, we're going to call John Doe. And the county here, we're going to call Ware County. And the cruiser, there's a spot here for the cruiser. I'll put me, Tommy Peagler. So I'm going to put T. Peagler here for the cruiser. The date, is August the 12th. My brother's birthday today. The plot size is 1/10 of an acre. Okay. We talked earlier about the plot size. That is 37 feet 2 inches. So we're going out a radius. We're going to be going out 37.2, 37.2, 37.2, all the way around in a circle, okay, to where we started. Okay. So I'll create a starting point in just a minute. We're going to go out 37.2, which is 1/10 of an acre, and we're going to tally every merchantable tree. That is a sellable tree that can be sold at a local mill. Okay, we're going to be tallying that. Number of plots. We don't know how many plots yet. This would be plot 1. Okay, but I also have a place here in my tally book that I can place the number of plots. I have categories in the tally book: pine pulpwood, hardwood pulpwood, which we do not have any hardwood pulpwood today. This is all planted pine. Pine chip and saw. We do have some pine chip and saw in here, not a lot. This is mostly pine pulpwood. We will not have any pine saw timber, which is like a 16 dBH and up. We don't have anything that would be 16 dBH, and then we don't have any pine poles in here. So the next thing we're going to do is we're going to actually start taking some timber data on our cruise plot. All right, we're on our plot, and we want to start getting some data from our trees. We want to start tallying. So each tree that we go measure is termed a tally, or a tally tree. And that tree, if it's inside of 37 feet 2 inches, is considered to be inside the plot. So as I start here, I have my tally book ready. I have my landowner's name, John Doe, Ware County, my name, Tommy Peagler, the date, 8/12/2020. The plot size is 1/10 acre, and I'm ready to start getting my tally info. Okay, so my first tree that I see as I work here is off in a distance. The trees are in rows, so I'm going to start, and I'm going to start my tally, and I'm going to work counterclockwise. It doesn't really matter. Some people like to work clockwise. I personally have got into a routine of working counterclockwise. When you look off in a distance, you can imagine 37 feet 2 inches. Okay, so you can say, hey, I feel like that tree's 50 feet away, or that tree's 20 feet away. But one of the first things you need to do on a new plot when we just get started is you need to get your eye set to distance. And one of the ways we do that is we actually start our plot, and we're always going to walk to our trees to see if they're in, particularly when we're starting a plot, and also those trees that may be on the edge of our plot. Is it 38 feet? Is it 37 feet? If it's 40 feet, it's out. If it's 38 feet, it's out. 37 feet would be inside of 37.2. So I want to go check my first tree, and I see in the distance, I see a tree that's got a bad fusiform rust canker on it. But I think that tree right on this side of that will be my first tree in my plot. I want to go see if it's in. So I'm going to pace over to my tree just to see if that tree is in. So it took me 8 paces to get over here to this tree. Okay? So now I'm going to measure the tree. All right? Remember, my diameter tape, or logger's tape, is calibrated. On one side is inches and feet. So I'll be able to measure from this tree back to my plot stick to see if it's actually inside of 37 feet 2 inches. On the other side, it's calibrated for diameter. You see how big this tree is. I want to check the diameter while I'm here. So I'm at the tree. We don't know the distance yet from this tree back to my plot stick. But I'm going to go ahead while I'm here, and I'm going to check this tree. It took me 8 paces to get to this first tree on my first plot. So I'm going to check it, and let's see what the diameter is of this tree. So I wrap my tape around the tree. There's my 0. Okay. So there's my 9. So 1, 2, 3, 4, 5, 6, 7, 8. So this is a 9.8. okay? This is a 9.8. So a 9.8 is actually going to be a 10, okay? So if we look on the tally book, okay, I've got John Doe, Ware County, my name, and then this is pine pulpwood here, 6, 8, 10. This is DBH, which is diameter at breast height. So that measurement that I just got is the diameter, or DBH. It was a 9.8. Odd measured trees go up. So I would put this as a 10. And is this tree big enough, okay, for chip and saw? Well, yes. So this is pine chip and saw, and this is pine pulpwood. This is a 9.8, so I could tally it here, or I could make my first tally right here in pulpwood. As I look at the tree, it's got a lot of limbs on it, and it's got some crook to it. Personally, I don't like to push my products, a product being pine pulp or pine chip and saw. So, assuming this tree is in, which we haven't figured yet, I would put this as a 10 pulpwood, okay? Next thing I want to do, now that I've established that the size of the tree, or the diameter of the tree at breast height, called DBH, I want to be able to pull my tape back to my plot stick to see if this tree is indeed in. As you approach the tree, you want to make sure that you measure the tree at what they call DBH. DBH is diameter at breast height, okay? It's 4.5 feet off the ground. So for me, I want to measure the tree in this area right here. Always make sure that your tape is good and straight and snug. Some people have a tendency to let their tape lay. And if I let my tape lay like that, that's showing me a measurement of 11.4. So what an error, when actually this DBH done correctly, this DBH is a 9.8 DBH if it's done correctly. So make sure you address the tree, you pull your tape around the tree snugly, and you measure off your diameter. Now that I've got my diameter, I want to measure back and see if this tree is indeed in. We said the diameter of this tree was 9.8. Okay. 9.5678. 9.8. Okay. Now I'm going to walk back to my plot stick to see if this tree is in. I'm going to check and see if that tree was in the plot. And it is not in the plot. This tree is 38 and 2 inches. For it to be in, or a tally tree that I can use that's inside of my 10th acre radius of 37.2, it's got to be inside of that 37.2, and this is 1 foot out. So now I know basically what I'm going to be looking at here in terms of what my radius is going to be like. Also, something that I did, I paced out to that tree, and I paced 8 paces. So 2 natural steps. So I paced out 8 paces. So really now, any tree that I'm unencumbered, that I basically pace to, that is 8 paces, is going to be right on the edge of my plot. And that may be a tree that I want to pull, that I want to check with my tape measure. So the next thing I want to do now that I know that tree is not in, is I want to go to my next tree that I see that is a little closer. It's the next tree around as I work around counterclockwise, and that'll be my next tally tree. So that tree will be in as I approach the next tree, now that I know what my distance is. So I'm back at my plot stick, and one of the things I found, the first tree that I paced out to, which was 8 paces, I measured the tree with my diameter tape, logger's tape, and it was a 9.8. which put it in a DBH of 10. Remember I said odd up. So if I'd have measured that tree and it had been a 7.6, it would have been tallied in my tally book as an 8. Okay, I measured that tree as a 9.8. It would be tallied in my tally book. It would go in actually as a 10. Okay, if I was tallying it. But I'm not tallying that tree. Remember, that tree was 38 feet and 2 inches. So now I know kind of what my plot's going to look like. I've got a starting point, okay? And one of the things I don't want to do is I don't want to double tally. So always remember where you started. One of the things that you can do to help you remember where you started is you could actually take a piece of tape and you can put it into the bark fissure of the bark, okay? So where this bark platelet is right here, a lot of times you can take a piece of tape and just hang it in there. Now, no landowner wants to have a bunch of flagging tape left in their woods. So make sure that if you use a piece of tape to mark your beginning of your plot, just make sure that before you leave, you take it out. So in this situation, I know that that tree that's 38 feet 2 inches is out. I know that tree out there that's between here and there, that tree's in. So I'm gonna make that my first tree. I'm actually gonna go hang this tape on it so I'll know as I make my way 360 degrees around this plot, I know I won't go past that. So this will be my marker. So I know I got to get a measurement on that tree, and I'm headed to that tree now, and I'm gonna put my flagging tape there and I'm gonna get started. All right, I'm at my first tree. Got my flag established where I can see it from my plot stick. This was the tree that was 38 feet 2 inches. So this tree was out. This tree we know is inside. 37.2 would probably be somewhere roughly right in here. So I know this tree is in. So this tree is going to be my first tally tree. Okay. One of the things I do, I want to look at the tree. I want to look at the form of the tree. As I look up this tree is really crooked. It's big enough that we could put it in chip and saw, but automatically, just because it's crooked, it won't make good lumber. It won't make good quality lumber. I'm gonna put this in pulpwood. So pulpwood, pine pulpwood, goes to make paper or fuel chips or fuel pellets. So I'm gonna measure this tree. So again, as I approach the tree, got my diameter tape. One side is calibrated to feet and inches. The other side is calibrated to diameter. I'm gonna make sure the feet and inches is facing the tree so the diameter will be out where I can read it. I address the tree at DBH, which is diameter at breast height, which is basically 4.5 feet above the ground. I measure the tree. It is a 9.7. Interesting, it's 1/10 of an inch smaller than the previous tree I measured that was out. So this is my first tally. Okay. Put my tape here to show that it's the tree I started on. So inside my tally book, I basically create a dot. And I use a method called a dot dash tally. And inside of my tally book, I've got pine pulpwood, DBH, and tally 6, 8, 10 inches. This was a 9.7 using 2-inch diameter classes. If you measure a tree and it's odd, you odd up. So a 9 is a 10. That's my first tree right there. So we've got our diameter measurement of the tree. Now we need to get a height measurement. We need 2 measurements to get the volume for this tree. We said the diameter of this tree was a 9.7, which is a 10 using 2-inch diameter classes. Remember I said odd up. If I'd have measured this tree, if it was a 7, say a 7.7, we would have tallied it in the tally book as an 8. This is a 9.7, I've already tallied it as a 10, okay? It's a little crooked, so we tallied it as a pine pulpwood, a 10-inch pine pulpwood. Got the diameter, now we need to get the height. So this is a clinometer, okay? I'm gonna step back 66 feet in just a few seconds, and I'm going to get a shot of this tree with this clinometer. When I look through the clinometer, I'm going to be looking at about a 2-inch top where the logger would cut the tree off before putting it on the log trailer. And then I'm going to look at the base of the tree of where a logger would cut this off at. Okay, I'm going to take those two together, add them together, and that's going to be my tree height. Okay, again, I'm going to measure where a logger would cut this tree off at. I'm going to come down and I'm going to take a shot down here where the logger would cut it off at. Okay, when the man on the cutout machine called a feller buncher, when he cuts this off down here, and then they drag it up and they load it, okay, they're going to put this whole tree, except for the very top of the tree, on the log trailer. So I need the volume of this tree in my tally book so I can see how much this tree weighs, and then we can put a value on it later. So now I'm about to pace off. Remember, a pace is 2 natural steps. I'm about to pace off one chain, which is 66 feet, and I'm going to take a shot of this tree and we're going to get a tree height. So I've left my initial tree that we tallied. Okay, it was a 9.7, so we put it in a 10-inch DBH class. I've paced off, which is 2 natural steps. I paced off 14 paces, which is 1 chain from that tree to here. I have my clinometer in my hand, and I want to look at the top of the tree at the point where the logger would cut the tree off for it to go to the mill, which would be a 2-inch top for pine pulpwood. Then I want to come down the tree with my clinometer, and I want to get the base of the tree where that logger would sever the tree with the feller buncher, the machine that cuts the tree. So, taking a look through my clinometer, and people have all kind of different ways of looking. Some people have both eyes open. A lot of people have both eyes open. For me, I actually close one eye when I look at it. I'm looking at the left-hand side. There's 2 sides. There's one that's the right-hand side of this is calibrated for 100 feet. The left-hand side is calibrated for 66 feet or 1 chain. I'm 1 chain away from my tree. So I look up at the top of that tree at where it would be cut off, and it is 36 feet. I'm going to add what I get on my bottom. It is 6 feet. So we had 36 and 6. That's a 42 feet tall. Okay. So the next thing I do is I'm going to go into my tally book. I'm going to find that 10-inch tree that I tallied, and I'm going to do a sample height of 42 feet. So now I have a sample diameter that I've taken, and now I have a height that I just got with my clinometer. So now I'm going back to my plot center and start going around my plot and getting some more measurements. Okay, so we got our first measurement. We got our diameter. Our first tree was a 9.7. It's a little crooked, so we put it in pulpwood. Remember our 2-inch diameter class rule, odd up. It was a 9.7, so we put it in a 10-inch diameter class as pulpwood. I paced off 66 feet, and I got the height of that tree, and that tree was 42 feet tall, that 10-inch tree. Now I'm going to my second tree. Okay, so this stick, by the way, is always home base. So I try to pretty much work from my plot stick. So always come back to your plot stick before you start heading off. So I'm gonna walk right here to tree number 2. I know it's in because I know it's in 37 feet 2 inches. So as I come up to my tree, I want to measure it at diameter at breast height, which is DBH. So I measured this tree as a 9.12345. So this is a 9.5, okay? So this is close to the same size tree that is. This tree is pretty straight. Let me tell you the problem with this tree, right here. This tree has a canker spot or a fusiform rust spot. They do not want this at the sawmills or the chipping sawmills. So this will cause this tree to be put in pulpwood, okay? So you can kind of start making some time once you get going with this. This was another 10. We've already got a height on that other tree over there we started with, so basically I just put a dot next to that tree, or that other dot. Okay, so far we have 2 dots by my 10, and we have 42 feet tall. Now when we start getting to some 6s and 8s and 12s and 14s, I'm going to get a height. So when we get any more diameters here, I will actually get some height for the other diameters. So now I'm ready to go to my next tree. This is going to be our 3rd tree in our tally. Okay, so this tree is inside of 37 feet 2 inches. Okay, so I want to get a measurement on this tree, and this tree looks to be a little smaller than the first 2 trees that I measured. Let me see. So I'm measuring a tree at DBH at 4.5 feet. It is a 6/8, okay, which makes it in a 6-inch diameter class. Okay, I look at the form, and it's pretty straight, but a 6-inch tree is so small that it's always going to be pulpwood. So I don't have any options for my 6. Okay, it's just going to be a dot tally. So for my 6, basically I just put a dot tally right there. But what I do not have HTS here, stands for heights. I have a 42 foot 10, but every time I have a DBH change, I need to get a height. So that's the next step for me, is to walk off from this tree 66 feet and to get a height for this tree. Okay, so I'm 66 feet away, which is 14 paces for me. And now I want to get a shot of that tree that is a 6-inch tree that I do not have a height for. So I'm going to look at the left-hand side of my clinometer, which is calibrated to 1 chain, or 66 feet. So my top height is 30, and my bottom height is 5. Okay, so 35 feet. So remember, my first 2 trees were 10-inch trees, and they have heights of 42 feet. My 6-inch tree, smaller diameter, shorter height, has a height of 35 feet. Okay, now, so when I get to an 8, if I have an 8, and I think I'm coming up on an 8-inch tree here in a minute, I'll need to get a height for that. So I've got a height for a 6, and my 2 10s, I have a height for them at 42 feet. Now I'm going back to my base to my crew stick and start tallying some more. So we've had 1, 2, my first 2 trees were 9-inch trees, which went up to a 10. My next tree was a 6/8, which is a 6, and now I'm about to approach my 4th tree in the plot. So I know this tree's in, it's very close to me. It actually looks like an 8. So as I approach the tree, I'm going to go around the tree at DBH, diameter at breast height, 4.5 feet. And as I measure the tree, it's an 8.1, 2, 3, 4, 5, 6, 7. So this is an 8.7. I look up at the tree, and in my tally book, I could have an 8. Sometimes can be chip and saw, but it has to be a really good tree to be an 8 chip and saw. And in my tally sheet, there's a spot for 8 chip and saw, but this tree is crooked, and the quality of the tree is not there, and also the height is not there. So I'm going to put this tree as an 8-inch pulpwood. Okay, so I basically did another dot on my tally book. Okay, so notice I've had a 6, I just took that 8, and I got 2 10s. There's my 35 feet tall for my 6 and my 42 for my 10. Now logic would have it that my 8-inch height would be somewhere between 35 and 42, but let's see. So now I need to get a height on my 8-inch tree. So I'm gonna pace away from the tree, 14 paces, which is 66 feet. I'm gonna shoot 2 inches, or 2-inch top. Okay, I'm gonna come down from the top, and then I'm gonna shoot the bottom, and I'm gonna see what the height of this tree is. 1, 2. Take out my clinometer. This tree, I've got a real good line of sight. So I look at the top, come down a little bit to where the logger would cut it off at 2 inches. So it would go to the mill, looking on my left side, and I have 34 feet. I look on my left side down at the bottom where the tree would be cut off at, and I have 4 feet, 4, bottom, 34 at the top. So I got a tree that's 38 feet tall. And that makes sense. That makes sense because my 6-inch tree was 35. My 2 10s that I've got so far were 42, and my 8 is 38. So now I'm going back to my home base, my crew stick. Okay, so I'm at a tree right here that I've measured, and it's a 8.8. Pretty straight, and I'm gonna put it as a chip and saw tree. I have tallied so far 4 6s, 8 8s, and 2 10s. So basically I've tallied 14 trees, and I'm just now finding a chip and saw tree, okay, that will make a chip and saw. So one of the things I want to do, I want to show you the tally book, and so far what I'm looking at is I got 4 here, 35 feet tall 6s. I've got 8 8s that are 38 feet tall, and 2 10s that are 42 feet tall. And this is an 8.8. Okay, if you can see that. It's an 8.8. So I'm gonna put it in chip and saw. A lot of these trees are pretty short here for chip and saw. So I'm gonna put this tree as a 8 2.5 log. They have to be, these trees basically, pine chip and saw 8. These trees have to be at least 33 feet to be able to go to the chip and saw mill, and they have to have a 5-inch top. I don't know if you can see that on there. So these trees are fairly, if you notice it, the trees are 35, 38, and 42. So we don't have a lot of chip and saw here because of quality and also because of height. So I did want to show you that. So my 15th tree of tallying is a chip and saw tree. My last tree, my plot, it is a 9-1. Remember, odd up, so we're putting them in 2-inch diameter classes. So that will be a 10. Okay. All right, so we had, and I'll show you this in just a second. So this is the last tree. When I finished up, we had 5 6-inch trees, 16 8s, so 8-inch. An 8-inch size tree was the majority of trees in here, and I had 8 10-inch trees, okay, for a total of 29 trees. So I had 29 trees in my plot. Remember, think about this a second. If I just did a 1/10 acre and I had 29 trees in my plot, okay, and I blew this up by 10, okay, that gives me 290 trees per acre, okay? Just a rough idea of what this is running. Like I said, if I have 29 trees I tallied in a 1/10 acre plot, which our plot radius is 37.2, if I blow that up by 10, I have 290 trees per acre. when I finished my plot, hang on a second, I just saw something. I actually remember that one chip and saw tree that I tallied. I need to add that in, okay? So I actually ended up with 29 pulpwood trees and one chip and saw tree for a total of 30 trees, or 300 trees per acre, okay? So I had 29 pulpwood trees and I had one chip and saw tree. Now you may be saying, the one chip and saw tree, would you keep that? Yes, because when we get through with the whole tract, the whole stand of timber, we may have more than just one chip and saw tree. So when we cut this timber, we could end up with a load, maybe 2 loads of chip and saw in here, but predominantly we have pulpwood. So I'm going to try to show you my tally book here, if I can. We ended up with 5 6 dBH trees. There's my tally, dot dash tally. We had 10 and 6 here, so we had 16 8s. We had 8 10s for a total of 29 trees for pulpwood. We had 1 8-inch tree chip and saw, so we had a total of 30 trees, or 300 trees per acre. Now the next step that we have to do is we need to go see how much volume we have. So we're going to transpose the information off of the tally sheet onto a worksheet that actually has volumes per tree. Okay, once we do that, we can see how much volume of timber we have out here on this particular plot we did. Then we can blow it up by 10 to figure out how much it's going to be per acre, and then we can blow it up by the total acres here and get an idea of what's the total volume on this stand of planted slash pulpwood. Well, back in the classroom, one of the neat things about cruising timber is we've been in the woods this morning gathering data, and typically that's kind of the way it is. You spend a good bit of time outside, but you spend a good bit of time inside. You have to do a good job in both areas. You have to do a good job outside gathering data, which we've been doing this morning in those planted pines. Now we've come in, we've got our data in our tally book, and now we're gonna sit down in here and we're gonna transpose our information from our tally sheet onto our worksheet computation form, so we can actually go from standing trees where we gathered the dBH and the heights and we tallied them in our tally book, and now we can transpose them and we can see how much timber volume is out there. So let's do that now. Okay, so here we are. So I have my tally book, and inside my tally book I have my tally sheet where I was gathering my tree data. So one of the first things I'm going to do is I'm going to come up here and I'm going to transpose the landowner here we're calling John Doe. For landowner, our county was Ware. Our cruiser is me, Tommy Peagler. So I'm just going to put T Peagler. Today's date is August the 12th of 2020. Our timbered acres, that's a small tract, our stand of timber that we're in this morning. So our timbered acres there is 7. Our cruised acres, and we only put in 1 plot in our sample, okay? So we only cruised 1/10 of an acre. So our cruised acres is going to be 0.1, because we only cruised 1/10 of an acre. So our cruised acres is 0.1, okay? If we had done 2 plots, we would have cruised 0.2, or 2/10 of an acre, okay? Now we got to come up to a percent cruise. A percent cruise is actually what percent of all the trees on the 7 acres did we physically touch? Okay? So we're going to do that by saying 7 divided by 0.1 equals 70. Okay? In this case, this is our blow-up factor. Okay? So 7 timbered acres divided by 0.1 cruised acres gives us a blow-up factor of 70. Our blow-up factor is what we're going to blow all of our volumes that we come up with from that one plot. Once we transpose this information over here, we're going to blow that up by 70. Now our percent cruise is 0.1 divided by 7, okay, which is 0.014, okay? We physically touched with one plot a little over 1% of the entire population, or the entire number of trees that's out there. So in a normal cruise, you would want to put in more than one plot. But today for our sample, we did 1/10 acre plot. So we cruised 0.1 or 1/10 of an acre on 7 acres. We physically touched on that one plot 0.014, or a little over 1% of the population is what we touched in our sample. In my opinion, if I was cruising that for a landowner, that would not be enough plots. But for our sample, that's what we did today. Our blow-up factor is the number that we're going to use after we figure what our volume is for that one plot. How do we blow up that plot to resemble the 7 acres? Okay, times 70 is what we're going to be looking at. Okay, so now let's just transpose our information over here. Okay, we had 5 6-inch trees that were 35 feet tall. So I come up here in my table and I said 6 inches, which is a tree from 5.0 to 6.9, that is greater than 31, and it's 35, is considered a tall. And we had 5 of those. So I'm going to write in 5 tall 6-inch trees because they were 35 feet, and in my table up here, if it's over 31, it's tall. Okay, for my 8s, I had 16 8s at 38 feet. Okay, anything over 36 is tall, so my 8s are also tall. I had 16 of them. For 10, I had 8 at 42. 41 are taller for 10. 41 height or taller is considered tall for 10. So my 10s are also tall, so I had 8 of those. Okay. Now, the product is pine pulpwood. Okay. Remember, we had 1 chip and saw tree, 2.5 or 40 feet. So 2.5 logs, a log is 16 feet. So 16 times 2.5 is 40. So we had 1 chip and saw tree. That was an 8 tall, okay? And we're going to put this product as chip and saw. Okay? So now I'm simply doing math. So I said 0.14 times 5 0.7 0.31 times 16, 4.96, 0.53 times 8, 44.24. Now I'm going to add those up. 0.7 plus 4.96 plus 4.24 equals 9.9 cruise tons. Okay, so I had 9.9 cruise tons on one plot. Okay, my blow up factor is 70, so I'm going to multiply that times 70. So 9.9 times 70 is 693 total tons, okay, of pine pulpwood. We had one chip and saw tree at 0.31, so just bring that down, add that up, 0.31. Now 0.31 times 70, 21.7. I'm going to say 22, 21.7 or 22 tons. So we have 693 tons of pulpwood. We have 22 tons of chip and saw. Okay, so now we want to see what is that running per acre. Okay, so if we said that we had 693 tons of pulpwood on our 7 acres, basically we just take 693 divided by 7, or we had 99 tons per acre. Okay, for our chip and saw, if we said 22 divided by 7 acres in our stand, we had 3.14 tons per acre of pine chip and saw. Okay, and this is pine pulpwood. Now, we have our volume. The next thing we want to do is we want to determine how much money is this. Okay, so using some of the local mills, let's just say that that mill is paying a delivered price of $30 per ton. Okay, let's say a typical logging rate is $10 per ton. Okay, that's for the logger for you to hire a logger to go out and harvest your trees. The typical hauling rate to get that wood hauled from your tract, this stand, to the mill is $6 a ton. Notice that I'm taking the delivered price and I'm subtracting what it would cost to get a logger to cut it, someone to haul it. Okay, so what I have left over is $30 for delivered wood minus 10 for the logger, brings us down to 20, minus 6 to haul it, brings us down to $14 per ton. Okay, we said we had 693 tons of pulpwood. So at $14 a ton, at 693 tons, okay, so 14 times 693 equals $9,702. Okay, so for our pulpwood, for that 7 acres, we could pay the landowner $9,702 based on our finding, our estimated appraisal of pine pulpwood tons at 693 times $14 a ton gives us $9,702. Now for the chip and saw, we said that the delivered price for pulpwood was $30 a ton. Chip and saw is timber that would go to make 2x4s, 2x6s, more structured lumber. That price delivered is a little more. That price would be $40 a ton. And this is just estimates, okay? So using our same logging rate of paying the logger $10 a ton, paying the hauler $6 a ton, we would say 40 minus 10 is 30, minus 6 is 24. So for the chipping saw, we could pay $24 a ton, okay? But remember, we didn't have but one tree in that plot. We had 30 total trees, and one tree was a chipping saw tree. 29 trees were pulpwood. So we only had 22 total tons of chipping saw, okay? So we say 24 times 22 tons is $528, okay, for chipping saw. So let's add those up. So we had 9,702 pulpwood plus 528 for a chipping saw gives us a grand total of $10,230, okay, on that 7 acres. So just for curiosity's sake, let's divide the total dollars by the acres, which was 7, and we have 10,230 divided by 7 acres gives us $1,461.43 per acre, okay? So on the total 7 acres, after our timber cruise, we had $10,230 divided by 7 acres to get us back to what it's running per acre. We had $1,461.43 per acre. Okay, so that's basically that's the way we transpose our tally sheet over to our computation form, also called our worksheet, and that's how we work through our worksheet, and that's how we applied prices from the mill minus the logging rate, the haul rate. We come up with this price for pulpwood was $14 a ton, also called stumpage, which is what you're going to pay the landowner. And we did the same thing for chipping saw, $40 minus 10 for the logger to cut it, minus 6 for the hauler to get it to the mill. Leaves the landowner at $24, and only 22 tons were out there. So we ended up with $528. So that's the way you get back in the classroom or your pickup truck or wherever you have an opportunity to transpose the tally sheet numbers to the worksheet so you can work it up and see how much timber that you have on your property. Okay, so we've discussed transposing our tally sheet, where we went out in the woods and gathered information in our planted pine stand today, and we came in and we transposed that information over to our worksheet so we could work up the timber volume, and then we worked through the price for the wood. And now that you've established a price for the wood, it's time to carry the price to the landowner to see if they're interested in selling their timber. Some people would take this information and use it for management purposes, as far as, you know, how their timber's growing, what's it worth, just for their knowledge. Other landowners would want to know, you know, I want to sell my timber, what's my timber worth? And by providing this information to them, they're able to decide, yes, I want to cut my timber, and then you go from there. There are steps beyond that we can talk about later. Once that landowner accepts this appraisal, you enter into a timber contract with them. You establish guidelines in terms of easement and access to the property. You talk about you know, not cutting too close to their streams, using wise management practices called best management practices for Georgia, and Sustainable Forestry Initiative called SFI. You want to make sure all those are abided by when you log their timber, and you want to put that in the timber contract. So that's something we can talk about later, but for today, that's going to cover us putting some plots in, or one plot in, and then coming in and transposing our information so we can get timber volumes and prices. So thank you very much, and I appreciate the opportunity to talk with you.